Okay, let's do problem 21. It says a circle is inscribed in an equilateral triangle. So I'm going to do my best to draw an equilateral triangle. That's alright. Oh, a circle is inscribed inside it. Okay, so there's my inscribed circle. Alright, ignore that other line. What do I want to know? So what is the ratio of the area to the circle to the area of the triangle? So I need to figure out the area of the circle and the area of the triangle. Well, obviously I need to introduce some variables to describe things like side lengths and radii here. So I'm gonna add some stuff to the picture that begin to make this problem solvable. So I think I'm gonna draw lines sort of straight out this way. And I'm doing that because it seems like kind of a natural place to connect. It's got a right angle here, and I know that we can do a lot of stuff with right triangles. So I actually don't have a right triangle quite yet, but if I extend this that way... So now I've got a bunch of right triangles. You see the right triangle right there. So let's figure this out. I'm going to put some labels on things. So this distance right here is the radius of the circle, so I'm going to call it r. I might call this entire side length of the triangle x, which would make this part x over 2, because it's half that entire length. I don't know what this distance here is, but I'm not going to worry about that for the moment. So let's focus on what do we want to know. I want to know what's the ratio of what? The area of the circle to the area of the triangle. So the area of the circle, I know, is going to be pi r squared. The area of the triangle, well, in general, let's see, I could do this by multiplying the base, x, by the height, whatever that is. A different way that I could do it is, it looks like I've divided this up into little tiny triangles. So let's see, 1, 2, 3, 4, 5, 6 of those. So if I could find the area of each one of these tiny triangles, the area of the big triangle is going to be 6 times the area of the tiny triangle. And that seems to me maybe it's going to be one step easier because I already have variables to describe the sides of this, and then I won't have to worry about sort of calculating this height here. So let's do it that way. And I want to find the ratio of those things, so I want to figure out like what is this divided by that. Alright, so far so good. So it seems like I can do this if I just solve for the area of the tiny triangle. So let's try and figure that out. What else do I know here? It would be helpful maybe if I could find one of these angles. This central angle seems like a really strong candidate. Because I know that this angle is the same as... Well, let's put it this way. So these two are the same. They're both theta. And you can tell that because these are congruent triangles here. So the angle all the way around here is 2 pi, because it's like a full circle. So if I'm going to divide 2 pi into 6 equal portions, that means theta must be equal to 2 pi divided by 6 parts. Alright, so I've got my theta. What else can I do here? So the area of the small triangle, which I was calling a tiny triangle, is going to be 1/2 base times height. So 1/2, the base is x over 2. The height here looks like it's r. Okay, so far so good. So let's go ahead and start substituting some stuff in. So my final answer, I know, was supposed to be the ratio of those two areas. So this divided by that. So let's do pi r squared divided by 6 times the area of the tiny triangle, which is 1/2 times x over 2 times r. Okay, so far so good. So I get an r canceling with this r up here. This is a sort of a 4 in the denominator there, which I'll move to the top. So I've got 4 pi r over 6x on the bottom. And like you could simplify that, I guess, if you want. Okay, well, so can I leave it like this? It seems like I shouldn't, because it seems like the ratio of those two areas shouldn't actually depend on the size of anything. Like, I could make this whatever size I want, and that ratio of the areas should remain the same, because the amount of space that the circle takes up compared to the triangle doesn't depend on the size of the shapes involved. So I know I should be able to simplify away this x and this r. So my goal is, let's try and rewrite x in terms of r, or the other way around, to like keep the simplification going. So let's see, I guess. So it seems like straight up SOHCAHTOA should work here. So if I have the tangent of theta, that should be equal to this side divided by that side. So tan theta equals x over 2 divided by r. So I think maybe I'm going to solve for x here. So let's isolate x in this equation so that way I can substitute it in for the x down here, and then my r's will cancel. So I'm going to multiply through by r and then by 2. So I've got 2r tan theta, and remember theta was 2 pi over 6, equals x. Okay, great. So now I can substitute that in, and my final answer is going to be 4 pi r divided by 6 times 2r tangent 2 pi over 6. So now my last two r's cancel, and if you look at this, these are all numbers. So my final answer should be a constant, which is what I expect it to be because of what I said before. Like, I expect this ratio to be constant because it doesn't depend on the size of r or x. If you want to, you can simplify this out the rest of the way. You should know what tangent 2 pi over 6 is. You can just think about it on the unit circle and so forth. I'm not going to do that right now because I think the most important thing to focus on was this problem-solving process. So let's go back and identify like a couple of key moments. I think key moment number 1 is draw a picture, always. Key moment number 2 is write in everything you know. So, like, label important things with variable names, and try and figure out what else you know. Like, it might not have occurred to you right away that you can find what this angle theta is, but once you've drawn the picture and you think like, okay, maybe this triangle is important somehow, finding out as much as you can about that triangle is probably going to help you solve the problem in the end. So, draw a picture, label variables with things that are important, find out as much as you can about the relevant shapes, and then just focus on what it is you're trying to figure out so that you can take your original problem and break it down into smaller pieces. So I know I can solve the whole thing if only I can find these two areas. Okay, I know I can find this area if only I can find this smaller area. So chipping away at your problem incrementally like that and keeping track of where are you and where did you come from so that you can combine all your work correctly at the end. Okay, good luck.